We'll be hearing a lot about that today. Particularly tomorrow, we really focus almost the whole day on edge devices. And some people have different definitions of what is the edge. It can be the edge of the network. It could be consumer networking. It could be a client device like a phone or a PC. We kind of lump all of that into the term edge. But no matter how you look at it, we do see more AI happening in those types of devices. Today, it's true, most of the neural network applications execute in the cloud, in a data center somewhere. For example, if you talk to your phone, hey Google, your voice is going to go up to the Google cloud. That's going to get processed, decoded, and then an answer to your request is going to come down, from the cloud and then be played out of your device. But one of the problems we see with that is that as these services become more and more popular, then the cloud vendors are having to add more and more servers to their data centers, and this is becoming expensive. So if you can shift some of that processing onto the edge device, onto a smart speaker, onto a phone, then it takes some of the load off of the cloud. And there's other issues. For example, latency. It's going to be a faster response if you can do the processing on your own device. Privacy is enhanced by keeping the information on your own device. Reliability, if I lose my connection to the cloud, I still have some functions in my own device. So for these reasons, a lot of reasons, we see a trend toward moving processing into the client. On the smartphone side, we've seen almost all of the leading smartphones, the premium flagship phones, now have some sort of hardware AI acceleration built in. Everyone from Apple, Samsung, Huawei, Qualcomm-based phones, MediaTek-based phones have this AI accelerator. And in fact, we're seeing second and third generation accelerators being built into these chips. And now the competition is not whether you have one, but how good is it? And so we're starting to see the performance ratcheting up in each generation. As these accelerators become more powerful, then the capabilities that they can perform become more powerful as well. For example, the new Google Pixel phone can do at speed voice recognition directly from the phone without accessing the cloud. So these capabilities now are adding value to the phones and driving the phone makers to put more capabilities, more AI capabilities into the hardware. As these capabilities become popular in high-end phones, then they will start trickling down into lower-cost phones as well. We've already seen some mid-premium phones in the $300 to $500 range adding these AI hardware accelerators, and I would expect that type of waterfalling to continue over the next few years down into even lower-cost phones. At the Internet of Things, there's a lot of other different kinds of devices. In particular, we see these voice assistants, either smart speakers or other devices that implement Alexa, that implement Siri, that implement Google, that people want to use not just to access the cloud, but to control things in their home, lighting, music. And as you're trying to do those sorts of functions, latency becomes important, reliability, privacy. So companies are making these smart speakers actually smart and not just conduits up to the cloud. And that is driving the inclusion of AI functions into these devices themselves. We also see activity in drones, trying to make drones more capable, self-piloting. We've seen the follow me in a drone. So the being able to put AI into those devices is also adding a lot of value. In industrial, we're seeing a lot of interest in IoT in general. we're seeing deployments of smart buildings and smart meters. The reason we're seeing this is because there's a strong business case that can be made. If you implement some of these smart capabilities in your business, you can reduce your heating costs, you can improve the ability of your tenants to enjoy the facility, and so it just makes financial sense to put some of these capabilities in. We're also seeing a drive towards smart cities. We're particularly seeing interest in security cameras, surveillance cameras, and those can be used for traffic management. They can be used for parking, and then of course in some countries are very focused on the surveillance of as well. But in any case, it's driving the deployment of a lot of AI into these smart cameras to create demand for AI chips. On the consumer side, there's been a slower takeoff of IoT, but we are starting to see more interest in some of the smart devices. The doorbells have been, Ring doorbells have been popular, and for example, the thermostats, and as well as some of the wearable devices, smart watches. Prices are coming down, so we're seeing more and more interest in these types of devices. The real barriers, I think, have been in ease of use, and as those are starting to be solved, we'll see more adoption. I mentioned smart cameras. Lots of interest in surveillance. Products like Intel, Myriad X, Chinese, lots of Chinese products here that fit into these cameras. They offer maybe 1 teraop, which is enough to run a neural network like the one shown here that does face recognition on multiple people in the frame at any given time at up to 30 frames per second. And these chips cost as little as $10 or less. So this market is already booming. There's already kind of a cost war going on, and so this is getting a lot of interest. And then even in these very small IoT devices, battery-operated devices like smoke detectors, that you can put a microcontroller in typically. I mean, you can run AI on a microcontroller, very simple types of things, but if you have an AI accelerator built in, then you extend the battery life of that device, and which is very critical to some applications. So we're seeing companies like ETA create microcontroller products with built-in AI accelerators, and we'll hear more from them tomorrow.